problem our group decided to tackle for this project was contamination of lead in the Great Lakes region across Canada and the US. Over 35 million people living near the Great Lakes are affected by this issue, and one of the major stakeholders is the fishing industry. As a group, we decided to narrow down our scope by focusing on finding ways to prevent lead intoxication in marine wildlife in the Great Lakes region.
When creating our solution, we had 5 key design specifications in mind to ensure that our solution was optimal for the cause. First one being overall lead intoxication must be reduced in marine wildlife. Second, no further harm is done to the ecosystem of the marine wildlife. Third, our solution must efficiently reduce the amount of lead via extraction or the prevention of lead contaminating the waters. Fourth, our idea must last at least 1 year after creation. And finally, fish must remain edible, therefore we cannot contaminate them with any other chemicals rendering them inedible.
By following our design specifications and running multiple novel solutions through weighted decision matrices, we found our final proposed solution of sinker casings. These casings will be made out of aluminum and attached to existing lead sinkers primarily used by fishermen in the Great Lakes area. These will also be provided as an additional service pre-attached to be sold to fishermen.
The first solution explored was a welded lead sinker casing. These aluminum casings would be permanently welded together around the lead sinker. This prevents any lead from interacting with the water when used. They also include a loop at the top to ensure they can be easily attached to the fishing line. As the primary method of testing, the casings underwent water pressure tests in Fusion 360 to ensure that they could withstand the pressure experienced at typical fishing depths. They passed with a minimum safety factor of 9.487.
The second potential solution explored was a clamshell design similar to the welded lead sinker casings. These featured a hinge on one side and a cantilever snap fit mechanism on the other to lock them shut. These were designed as non-permanent solutions that may receive improved public acceptance because they can be removed by the user. Due to this fact, a rubber coating is included around the edges and interior to ensure a watertight seal when shut.
The clamshell casings underwent similar water testing to the welded sinker casings, passing with a minimum safety factor of 8.6 at maximum recreational depths.
To test our third prototype, we had 8 lead sinkers put into 2 different containers filled with water. One container had lead sinkers with flex space on them, while the other had no flex space on them. We let them sit for approximately a week to test how much lead was in each container at the end. The results showed that the container without flex space had a normal amount of lead, whereas the container with flex space had a marginal amount of lead. This concludes that our idea of placing a material around the lead sinkers was able to prevent lead contamination in bodies of water.
Some limitations to our project were we did not have aluminum welding material, so we couldn't weld onto the lead sinker. There's also about 500 tons of lead already in the Great Lakes that this project would not remove. And aluminum welders are in scarce supply in the Great Lakes region and would cost a lot to employ.
Even with these limitations, after further development, we've concluded that our product will make a decent impact on lead contamination in the Great Lakes. Our product ensures that we use lesser material, and instead of making the entire sinkers out of aluminum, we simply make the covering out of aluminum, ensuring that less material is used. Our solution ensures that we are sustainable with our project while combating the issue of lead intoxication in the Great Lakes region.